So let's see this problem on LeetCode, that is problem number 3191. That is minimum operations to make the binary array elements equal to 1. You are given a binary array nums. You can do the following operations on the array any number of times, possibly 0. And what are the operations? Choose any 3 consecutive elements from the sub array and flip all of them. Okay. Flipping an element means changing its value from 0 to 1 and from 1 to 0. Return the minimum number of operations required to make all elements in nums equal to 1. If it is impossible, return -1. Let's see the example. So this is the array that they have used as the example. So what is their answer? The answer is 3. That means the minimum number of operations required is 3 to make this array into an all ones array. Okay, by that shifting process that they just described. So what do they do? Choose the elements at indices 0, 1 and 2. 0, 1 and 2. The resulting array is nums 1, 0, 0. Why? Because okay, the first element is 0, so it has to be made into a 1. So you start from this, make it into a 1, but in the process these two also get flipped. So the result is 1, 0, 0. Okay, then since the resultant array is this, now they check 1, 2 and 3. Flip everything, becomes 1, 1, 0. Okay, next they go to this element but they do not do anything. Next they go to this and change everything. Okay, so let's see a dry run. I've used the same example. So this was the array that they took, and let's maintain a counter, that green pointer, that will help us traverse the entire array. So what does the algorithm wants us to do is, see, if you have an element say 0 at the starting index, whatever comes after that will be dealt afterwards. But since you see a 0, it has to be made into a 1, and there is nothing before that that can help this. Okay, so when you start and see a 0, it immediately has to be made into a 1. So they flip it. But in the process what happens is these two ones that you see also get flipped, then becomes a 1, 0, 0. Now since you have made this into a 1, you move further, and now the same story continues. You again see a 0, and if you skip this 0 and move further thinking of that I'll come and replace that afterwards, so there's no point. You might as well do it in this step only, because if you move further there is nobody that can help this 0, because you cannot toggle a bit that is to the left of your current bit. So if you're standing here, you cannot toggle this bit, you can only toggle the next two subsequent bits. So if you see a 0 anytime, you just flip it. The resultant elements that get flipped are the subsequent elements, which will be dealt when this green pointer reaches those elements. So this is the simple intuition behind solving this. So just see how do we proceed. So once you have maintained this green counter and you see a 0, what do? You flip. Yeah, and since you have just started traversing, you do not have any flip. The number of flips is obviously 0. Now when you start traversing, since you see a 0, this has to be converted into a 1 by just negation. But in the process, see, these two elements also get flipped. And now your green counter is at this element because it has to traverse. The increment is by 1 index. And the total number of flips is now 1. 1 flip has been done. Now since you are at this element, now you again see a 0. So what to do? To restore it back to a 1, you flip it again. But when you flip this 0 to make it into a 1, what else gets flipped. This will get flipped and this will get flipped. So see, this 0 flipped into a 1, this 0 became a 1 and this 1 became a 0. And where is your green counter now? Green counter is at this position. And how many flips have you done till now? 2 flips. Now since you see a 1, there is nothing to do with this one because it is already a 1. So you move further. So here is your green point. Now again you see a 0. What do? You flip it. But in the process, these 2 also gets flipped. But now you benefit from that. So total number of flips is 3. And now the green counter reaches this location. Now the point is, should you check for these 2 in your, when you are traversing? We'll get back to this when I just give you another example. But the whole point of the story is that you do not have to check for these 2 while you are traversing. And what are these 2? These 2 are the last 2 elements in your array. Let's see why. Say you have this case, this 0, 1, 1 and 1. You start traversing from the left. Currently you have 0 flips. Now to make this 0 into a 1, what do? You flip. But in the process, this also gets flipped and this also gets flipped. Now your green counter is at this and the total number of flips is 1. This gets converted by flipping, but this also gets converted and this also gets converted. Now you do this. Now since the green counter has reached this location, can you do something else? See, this is a 1, so nothing has to be done. That means you want to move ahead. But if you move ahead and try fixing this 0, there is bound to be 2 more operations also that are to the elements to the right and to the right of this right. But you do not have those elements in your array. That means you can never check for these 2 elements, last 2 elements in your array. Let's see another example. Say this was your original array. You started from this index, saw a 0, flipped it. Green counter moves to this location. You saw again a 0, you again flipped it. But in the process, now see, this is a 0 and you want to fix it. But if you try fixing this 0 and try converting it into a 1, okay, this gets into a 1, this gets flipped, but you also have to do one more operation on the next element also, because every time 3 elements are getting operated on. But you do not have scope for those because you only have 2 elements left in your array. So let's see another configuration. So this was your configuration. You started from this, 0 flips as usual at the start. You flipped. You again saw a 0. You again flipped. Now you are at this location. Now can you do anything else? If you try to make this into a 1, okay, this gets into a 1. This will also get into a 1. But you need one more element also. And there is no element in your array. So that means you can only be left with 3 possible configurations for the last 2 elements in your array. And what are those 2 configurations? Either you will be left with 0, 0 or a 0, 1, the last 2 elements only, or a 1, 0 or a 1, 1. So out of these 4 configurations, in which configuration would you guarantee that the sub-array or the array is completely consisting of 1s? Only for this case. Because making these 2 1s and preceding that, already we have made everything into a 1. If you see this example also, everything before the first 2 elements is already a 1. So the only problematic points for this problem is the last 2 positions. And these 2 will always settle down in one of these 4 configurations, out of which only this is your favorable case. So this is my favorable case, this is not my favorable case, this is not my favorable case, and this is also not my favorable case. So once you have started traversing and you have ended your traversals, you do not immediately return the number of flips, because as the problem statement said, see, the problem statement clearly mentioned that return the minimum number of operations required to make all elements in nums equal to 1. If it is impossible, return -1. And these are the 3 types of cases in which you get that -1 answer, because it is impossible to, because in these 3 cases it is impossible to convert your entire array into ones. So 2 things are to be noted. The first thing is, you do not traverse beyond, see, this is my 0th index, this is my first index, this is my second index, this is my third index. So whenever I traverse my for loop, whenever I keep traversing, the for loop's last point to be checked is only this point. That means if I have an array of size n, the last index is at n-1, before that you have the n-2th index, and before that you have the n-3th index. So the last point to be checked is only this index. You can never check for these two, because even if there was a problem, you cannot fix it, because every time the operations has to be done on 3 subsequent elements, and you do not have scope for 3 elements here. So this was the first observation, and the last observation, second observation is also this. Once you return, before returning, just check if nums of n-2 is equal to 0, or if nums of n-1 equal to 0, if this is true, that means there is no possible configuration in which you get 1 1 1 1 1, all ones. So that time you only have to return a -1. Else you return whatever the flip count you have accumulated till now. So this is the whole idea behind that. Let's see how to code this. So see, what do we have to maintain? First, just calculate the flips, that is initially 0, then the size of your array n. What else do we need? Okay, let's start traversing. Green starts from 0, and what is the last point? It has to be less than n-2, that is n-3 is the last index to be checked. Green plus plus. Now if the element at green is 0, that means you need to fix it. And what is the fixing? You toggle the greenth. A of green has to be equal to 1. A of green plus 1 is equal to the negation of A of green plus 1. A of green plus 2 is equal to the negation of A of green plus 2. Now once you have done that, your flips counts increases, nothing to be done more. Once you break out of this for loop, there is one more last condition that you need to check. If A of n-2 is equal to 0, or A of n-1 is equal to 0, you return -1, else you return the flips. Basically you can also avoid this, because it explicitly just sets that green, that 0th element to be 1. You don't need that. Either you can write this or you can avoid it. So if you avoid, then it's fine. Just okay, says just run this. There you have the test cases, all of them have passed. Okay, so this was all about this problem.